Hello, 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 and welcome biologists to the main event. This is what you all signed up for and what you're all excited for. I'm only half kidding because this is a dihybrid cross, and it's one of those ones where we're going to go through it very methodically the first time, and it's going to be a lot and a lot to do. And then after you do one or two, you start to notice patterns, remember numbers, and they all become a lot simpler. But I'm going to show you why everything is the way it is right now. And this is a very important video for you to pay attention to because it'll help you understand a lot of what's to come. So here we go. Dimples is a dominant trait. Both parents are heterozygous for both traits. That's saying both a lot, but that means both parents have all the alleles possible, so we're going to get a really big Punnett square. If Bobby and Whitney have children together, what will their genotypic and phenotypic ratio of their children be? All right, you ready? Because this is going to be a long one. So first thing we're going to do is the same as always. It's define your alleles. I'll give them to you, so you should be used to doing that by now. But just so we're on the same page for the rest of the problem, we're going to go with capital B for bushy eyebrows, because it's dominant. Lowercase b for thin eyebrows, recessive. Capital D for dimples. Lowercase d for no dimples. With that in mind, try to write out all the way up to gametes. So try to figure out the genotype of each parent and the gametes that each parent can produce. And I encourage you to pause this video and try to jump ahead to that like step 3 that we've been doing in all these problems. So I'll give you 5, 4, 3, 2. Have you paused it yet? Great. 1, and here we go. They're both heterozygotes, so that means they're both going to have a dominant and recessive allele for each trait. So we see that as a big B and a little b and a big D and a little d for both of them, because they're both heterozygous for both traits. Gametes-wise, this is where it gets fun. They can make 4 gametes each, because we have a dominant allele here paired with the other dominant, then dominant with recessive, then recessive with dominant, and recessive with recessive. So if we picture them like shuffling up, there's 4 possible ways they can mix. We get the homozygous dominant, we get a heterozygous, well, actually, again, I shouldn't use this speaking, but we get 2 dominant alleles. We get the dominant B, but recessive D. We get the recessive B, but dominant D, and we get 2 recessive alleles here. So there's 4 possible combinations, which means our Punnett square is going to be massive. I invite you to pause it here and try this Punnett square on your own. I very much do. This is one of those ones that you should kind of try and see what's going on and see why we're going to end up simplifying this a bit later on. Because, yeah, this is like a pillar of this unit. It's doing these big dihybrid crosses. See if you can line it up and see what you come up with. I'm going to hum some music for a second here and see what happens if we go. All right, you ready to come back? Fantastic. Wow, look at that. We're still going to label that female and male, female still on the top. I was able to get a color-coded thing to help you with the genotypes in the next page. But as you can see, we get a really big Punnett square here. It has 16 squares. So here we're just going to see we're matching up all the B's and all the D's. So we still group the alleles for each type of gene together. And then it's just a question of mixing them. So we go down from this box, we get a little b. Over from this box, we get a big B, big D, little d, um, and such, and that's great. And then based on the colors here, we see which phenotypes are actually the same, which I'm going to talk about shortly. But pause the video here and see if you match up. I just want to share, just in case you're not sure. This and this are the exact same. It doesn't matter what order you write the recessive and dominant. I typically like to put the dominant first just because it kind of looks cleaner. But these two genotypes, well, all the ones that are the same color mean the exact same thing genetically. So keep that in mind. For 5, we're going to get a couple new slides for the genotypic and phenotypic ratio because there's a lot to talk about here. So I'm going to break down the genotypic ratio that we see here into 2 individual crosses. So here you see if we try to like count this, this one's color coded so it's not as difficult, but imagine you just wrote this on pencil on a test. You don't want to have to deal with this. So if you make 2 crosses and kind of like imagine them like this, we can get the genotypic ratios for each cross for each individual trait. This is just crossing the B and the D separately. And then this is a preview of your probability lesson, which is gonna, well, it should already be up, and you're gonna be using that shortly. But here, what we can do is we can just multiply through. Where did that come from? That's magic. I'll explain this. So we have a 1 in 4 chance of getting a homozygous dominant genotype here, and a 1 in 4 chance of getting a homozygous dominant genotype here. 1/4 times 1/4, remember multiplying fractions from math class, that's 1/16. So that's where we get this. We get 1/16, our big B, big D, big D, big D. And there, we can do this for every single one. So I've just multiplied them through, like here, for instance, the heterozygotes. Heterozygotes, 1/2 comes 1/2 is 1/4 are heterozygous for both. Then I'm just going to organize this a little nicer so it looks clean. But what happens here is we notice a pattern. When you're looking at genotypes here, it's 1/16 for any time that it's all the homozygotes. So 1/16 for homozygous for each trait, homozygous, 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 homozygous. Those are the 1/16s when it's homozygous for like either trait or for both traits, sorry. And then you can like swap them up in 4 ways. You can have 2 homozygous recessives. You can have eyebrows be recessive, but dimples be dominant. You can have both dominant, or you can have eyebrows dominant and dimples recessive. But anytime you have 2 homozygous cases pairing, it's 1/16 chance. 1/8 chance is a heterozygous and a homozygous trait. So 1/8 here, we see it's heterozygous for eyebrows and homozygous for dimples. Same here, we have homozygous for dimples, heterozygous for eyebrows. Here, homozygous for eyebrows, heterozygous for dimples. These are all 1/8. Then our 1/4 are double heterozygotes. So 1/4 are heterozygous for both traits. Take a second here and write this down, or pause it, or make a note, or take a photo, because this is very important just to remember. Because after doing this once, I don't really want to do this again. I don't know about you, but just like if you remember these rules down here, this will guide you, and this could end up actually being a multiple choice question. It'll be like, what's the chance in this trait that you'll get a genotype of capital B, capital D, lowercase d? So homozygous dominant for eyebrows and heterozygous for dimples, which is here. And all you have to do to know that is know that, hey, it's 1/8 if it's a heterozygous and a homozygous. So that's all it is. If you just remember these numbers, then you don't even have to do this whole like square thing. Phenotype, I color-coded these for phenotype now. If they have a dominant allele, heterozygous or homozygous for both traits, that makes them one of these red ones. See, they all have a capital B and a capital D present. So we're going to see always 9/3 to 3/1. But I'm just going to go ahead here for a second. 9/16 have a dominant allele for both, so that means 56.25% are bushy eyebrows with dimples. 3 are dominant for one and recessive for the other. Therefore, 18.75% are bushy eyebrows with no dimples. That's these ones, these like light green ones. Then 18.75% are thin eyebrows with dimples. That's these ones here. And then only 1/16 have both recessive phenotypes. That's the one in the very bottom corner here. But again, you just have to remember 9/3/3/1 here. Similar to how we're remembering these genotype rules, like 16th, 8th, and quarter. Here, 9/3/3/1 means 9 will be dominant for both. 3 will be dominant for like the first one and recessive for the second. And the other 3 will be recessive for the first one and dominant for the second. So just like swapping off there. And then 1 will be recessive for everything. So again, take a photo here, because this is something you want to remember, and this could also be a multiple choice problem. These questions are super big and super messy looking, but when we just remember these rules, we can like abbreviate a lot of it, or just like make it a multiple choice, like, and you just have to remember 9/3/3/1 and then the quarter, 16th, 8th thing. So go back and review this video and match it up to your answer, and feel free to come back to this video throughout the whole course and even up to your exam, because this will help you get these dihybrid crosses right. Again, email me, mrbscience at mrbsciencemb@gmail.com with any questions, and I'm happy to help. Have a lovely day, biologists.